A warm welcome one and all. 2-week national workshop on educational research methodology, which is organized by Center for In-Service Teacher Education under National Sanskrit University, Tirupati. I heartily welcome Professor S. Khadiravan sir. Please take a session.
Okay. So morning we were discussed about the Pearson product moment correlation coefficient, and correlation coefficient is a single number which lies between -1 to +1 including 0. See, correlation talks about the direction and the extent to which the two variables are correlated, but we need the correlation coefficient just to make some interpretation. By calculating the correlation coefficient, we can convert the R value into T value and test the hypothesis. I think we have summarized like this. Correct? Up to which we have stopped. We have worked out the Pearson product moment correlation. Again, for me it's imposition, so I have to write the numbers once again. See, even when whenever I'm taking classes, I used to take 2 sessions or 3 sessions together for statistics, so that you need not repeat the numbers, you need not work out the same thing once again. Right. I'm coming back here. So morning we have started with the problem of product moment correlation coefficient. I said that for the same thing I will work out the rank order correlation coefficient. So the two scores, like these are the scores of the same people in both maths and science. Maths and science. This is a score in maths. These are all the scores in science. The same scores I am using, which was used in the product moment correlation coefficient, and see how they differ. That's why I am taking the same problem, the same numbers. So the numbers are 1, 7, 1, 7, 3, 5. The science scores 5, 1, 2, 8, 2, 6, 1. Is it visible? Is it visible? Yeah. These are the scores of the same people in 2 different subjects like maths and science, or science and social science, whatever it may be. Then the formula for the rank order correlation is, it is called as rho or R, 1 minus 6 sigma d square by n into n square minus 1 within the square root. Within the square root. Okay, how to find out this D? D is the difference between the ranks. D is the difference between the ranks. Then n, total number of cases in either group 1 or 2. Already I told you in the morning, for Pearson and rank order correlation, in both the group you have the equal numbers, not the numerical value is equal number. For example, in this group we have 10 cases, in this group we have 10 cases. So you must have equal numbers. Are you clear? Then, first you have to assign the rank. So for the first group the rank is called as rank 1, for the second group the rank is called as rank 2. How to assign the rank? Some of you are already teachers working in the schools and colleges. To assign the rank, okay, for the topmost score you will give the rank 1. Am I correct?
Yes, sir.
Am I right? If 2 people get the topmost score, come on.
No. Same.
If 2 people got the highest score,
Yes, sir.
what you will do?
Same rank.
Same rank, 1 and 1 will be given, and for the next rank you will give the rank 2.
No, third rank.
Are you sure?
Yes, sir.
But here it is little bit different. we will not assign the same score. We will not assign the same score, but because statistically we have to give the accurate number. We have to give the accurate number. There you cannot call the rank as 2.5, 3.5, 7.5, etc. That is why you assign the whole numbers. But here we will add the rank and divide the rank by 2 or 3, whatsoever it may be, and we have to assign the rank. We have to assign the rank. So let's see, what is the topmost score? 12. Am I right?
Yes.
Yeah. 12. Okay, rank number 1. Then what is the next score? 11. 2. Then what is the next score? 10. 3. What is the next score? 7. 4. What is the next score? 5. 2 times 5. Remember, rank number 5 and 6 should be used. The average of this rank is 5 divided by 2. 5.5. 5.5. So 5.5 and 5.5. So 5 is used, 6 is used. The next rank is 7. So for the next score, what is the next score? 4. Rank is 7. The next score? 3. Rank is 8. 9. 10. Hope there is no confusion. There is no confusion. Then the second set of scores. Highest score is 8. So rank number 1. Then 6. 2 and 3 position. 2 plus 3. 2.5. 2.5. Sorry. 2.5. 2.5. Then second and third rank over. So the next rank should be 4. So what's the next value? 5 is the next value, am I right? But we have 2 5s. So 4 and 5 should be used. So 4.5. 4.5. Correct?
Yes, sir.
Am I right?
Yes.
Okay, now what is the next value?
6th rank.
6th rank should be given for 4. Then 7th rank for 2.
2 times
2, 2. So 7.5, 7.5. Hope you are clear. Say the way you are listening. I am not showing. 7 and 8 is over. Then 9 and 10. 9.5, 9.5. Hope you got the clarity. Okay, purposefully it was given, so that you should not be confused. You want light or you don't want light?
We don't reflect.
It's glaring, reflecting. So this light should be switched off. Yes? Okay? Then, next we require, what we require is D. What is the difference in the rank? What is the difference in the rank? 10 difference 7.5, 2.5. 4 difference 4.5, 5.5. 9, 3, 6.5. 2, 7, 2.5. 1, 3.5. 1, 5.5, 2. 3 into 0.5. 5.5, 4. Am I right? Yes. Now we want the squared values. We want the squared values. Remember, difference is the numerical difference. We least bother about the sign. And one more thing, even if you include the sign, while you are squaring the value, the sign will be go up. The signs will be going up, so we need not bother, but we require the difference only. Then, what is the value of 2.5 into 2.5? 6.25. 0.5, 0.025. This is 42.5. If you want to check, you can check. Clear? So what I did was, first I assigned the rank. The ranking procedure is completely different. In the school or college ranking, first rank means if 2 people got the first rank, you will give the rank number 1 for both of them and you will start from the 3. The second condition is the same, but the first condition, we have to assign the fractional value here. We should not give the whole numbers. 1 cannot be given, right? The rank position, for example, 2 and 3 means 2 plus 3 divided by 2, we took the average, 2.5. For example, 2, 3, 4, 3 equal numbers. 2 plus 3 plus 4, that will be 3. So, The rank number 2 will not be there, rank number 4 will not be there, only 3 will be there for 3 times.
Yes.
Are you getting me? This is how you should assign the rank. This is how you should assign the rank. Then after assigning the rank, we should find the differences between the ranks. Rank 1 difference rank 2. Then we are squaring the values. We are squaring the values and we require sum d square. Sum d square. Sum d square value is 92.50. 92.50. So coming back to the formula, we want R is equals to 1 minus 6 into 92.5, sorry, 92.50 divided by n is 10, n square 10 square minus 1 under the square root. 1 minus 6 into 92.50. 6 into 92.50 is 555. 555. 10 into 10 square is 100 minus 1. This is 99. This is 99. So 1 minus 555 divided by 990. 1 minus 0.560. So it is 0.439. 0.439. 0.439 is the calculated R value with the rank order method. Do you remember the value from the Pearson product common correlation coefficient? This is 575. This is 575. See, this value is 575. This value is 0.439. This value is 0.439. Look at the values, look at the differences in the values. Look at the differences in the values. Why it occurs like this? If you use the same value, why it occurs like this? Why it occurred? See, morning only I think Babu Shankar has completed the nominal, ordinal, scale, etc. Am I right? That's what I heard of. Morning only has completed. In Carl Pearson product command, what we did was, we are directly multiplying the continuous values. We are multiplying the continuous values. So they are in the ratio scale. They are in the ratio scale. But now, we least bother about the values. We least bother about the values. Rather, we have assigned the ranks. We have assigned the position. Rank is nothing but the position. That is why, when you use the same value, in the rank order method, the correlation coefficient value will be lesser. Okay. Even forget about these numbers. You thought that just because it's multiplication of these numbers yielded the higher score. No. Even if you have 100 marks, 90, 85, 87 like that, even there the question will be 1, 2, 3, 4, 5, 6 only. So whatsoever the number here may be, this will be the same. Hope you got the difference. Hope you can understand. Now the rank or position is in the ordinal scale. Rank or position is in the ordinal scale. So, whenever the scale, there are certain properties for the scale, morning you would have discussed. Okay? It should help you to classify, that is the nominal scale. It should help you to position in the particular place, ordinal scale. Okay? It should give some equal interval scales. So each higher scale will possess the properties of the lesser scales or lower level scales. Ratio scale, it has the absolute 0 plus all the other thing. Plus all the other thing. Classification, position and interval. That's the advantage of the ratio scale. But morning itself I told you, ratio scale is not possible everywhere with the human measurement. Ratio scale is not possible with the human measurement because we cannot assume that our level of intelligence is 0. We cannot say that our previous learning is 0. Even kids know, kids have the intelligence. Kids perform so many activities better than us. Better than us. So we cannot assume the initial value as 0 with the ratio scale. Ratio scale it starts with 0. So ratio scale, utilization of the ratio scale with all the human abilities is not possible. Not possible. So depending on the purpose we are using it. Now we have the biggest question. Biggest question. Sir, whether this comes under the parametric statistics or non-parametric statistics. Parametric statistics or non-parametric statistics. So anybody is covering non-parametric, parametric and all, or let me touch upon it. No. If somebody is taking the parametric, non-parametric, I am not touching upon it. Yeah? I can touch it. Okay. See, whenever again we should go for the population. Sir, just open the other PPT. The first page of the PPT. That would be helpful. Yeah. First scale. First slide. Yeah, good. Yeah. So my next topic is I supposed to cover it. You will get all the material. PowerPoint, don't take the photo and waste your time and energy cell phone. Okay? It is available there. They will post it in your group. Materials are for sharing only. Sir, project it, sir. It's not projected. Slideshow. Or control F5 or shift F5. Oh, okay, fine. Coming back here. See, actually, you know about the population census. Population census. In population census, we used to go every door, every house. Nowadays we have only house, not the home. So we are going every house and tap the door and we call the person who is available inside. Whatever he or she is lying, we will write it down. Am I right? Sorry. Whatever he or she is giving the information, we will take it. We will take it. That's what the census. That's what the census. See, we are the salaried people. We are paying the income tax. And when the census wala comes, we will say our annual income is 18,000. We are the salaried and already we are paying the super tax, 32.4% tax. And we will give the information because we thought that the census people will reveal some information. In the census, the real purpose is if there are about 150 crores population, it is essential that each data or the information about each and every person in the country India should be collected. The country India has to be collected. This is the purpose of your census. Purpose of your census. But when we go for research, is it possible to collect the data with each and every fellow involved in that area or involved in that process? That is why we are assuming certain conditions. The first condition is, can I rub this?
Yes.
If you want, you can take the photo. It's not available. If you want to take a photo of this, it's not available in the PowerPoint. This I have worked out. I'll rub it. I have to touch upon so many things to give the inclusive picture. Yes? Actually, this is a topic for tomorrow, sampling. From where only we have to start. The parametric and non-parametric statistics. Yes, tomorrow we will be talking about the sampling. So, the census is for the entire population. This is for entire population. Okay, but conducting the survey with the whole population is impossible. Even the census is a failure, utter failure in all the countries. The population census itself is the utter failure. And you know as a teacher what you are doing. You will go and you know that there are 4 people in that house. Then you will write 4 and you will cook up some data. You will cook up, that is what the practice we are doing in the research also. So we will cook up some data. But that should not be the case in the research. So instead of the population, we are selecting the packet of people from this area. This packet. Likewise, we have taken the representative of the whole population. and we assume that the characteristics of these packets, we call it a sample technically. The characteristics of these packets will be the reflection of the whole population. Will be the reflection of the whole population. So the small portion or unit which is selected for measurement and analysis is known as sample. Which is taken for measurement and analysis is known as sample. Right. The values, the measurement of sample yield some numerical value like mean, standard deviation, etc. That is known as statistic. Morning I asked you, there is a difference between statistic and statistic subject. Okay? So the measurement of certain qualities of this sample yield some numerical value. That is known as statistic. It may be mean, it may be your median, it may be your standard deviation. Mean or median or standard deviation. Are you clear up to this point?
Yes.
Right. Values which are descriptive of the whole population is known as parameter. Values which are descriptive of the whole population is known as parameter. Parameter. Did you understand the difference? It's not possible to measure the whole population. So we select the packet of people from the whole population and we assume that the characteristics of this packet, okay, will reflect the characteristics of the whole population. Right. Then the measurement of the measurement with any entity of the sample yield some numerical value. That is known as statistic. That is known as statistic. Mean is the statistic. Median is the statistic. Standard deviation is the statistic. Are you clear up to this point? Then what we do is, since we are going for generalization, we will say the sample mean is the population mean. Sample mean is the population, because we cannot measure the population mean. We cannot measure the population mean, but we will generalize it based on certain conditions. We will generalize it based on certain conditions. The generalized value is called as parameter. The generalized, see, sample mean is indicated by M. Population mean is indicated by mu. Mu. Okay? The sample mean is indicated by M. Or sample mean is indicated by M mean. MEN mean, MEAN mean, so we call it as M. Or X bar. The symbol is also used for mean. This is X bar. This is X bar. X bar is mean. It indicates mean. Then, if we generalize the same value for the population, this is called as parameter. It's called as parameter. Parameter is indicated as mu. It's indicated as mu. Are you clear up to this point? Right. Sir, move this slide. That's what I have explained. Yeah, close this slide. Close this PPT. Then, coming back to the point. Now we are using some statistics that what are called as parametric statistics. The other statistics are called as non-parametric statistics. Or we use the technical term parametric test and non-parametric test. Non-parametric test. Okay. If we want to use the parametric statistics, there are certain conditions before which you know the analysis, statistical analysis. Statistical analysis. We can classify the statistical analysis into three categories. One is univariate analysis. Uni means single. Univariate analysis. The second one is bivariate analysis. Bi means two. Bivariate analysis. Third one is multivariate analysis. Yeah, super answer. You have written the course recently. Multivariate analysis. Are you clear with this? Just I am categorizing the statistical analysis as univariate, bivariate and multivariate analysis. Are you clear? What are the univariate analysis? Number 1, your measures of central tendency. Measures of central tendency including your mean, median, mode. These are all the univariate analysis. Mean, median, mode. Then measures of dispersion or deviation. Dispersion or deviation. Okay? There comes your range, quartile deviation, standard deviation and average deviation, mean deviation. Quartile deviation, come on, write it down. I cannot write everything in the board. Okay? Measures of dispersion or deviation. Measures of dispersion or see, on seeing your variables from this chart, you can decide which statistics has to be used. Okay? These are all here. Measures of dispersion or deviation. Okay? Range normally cannot be used as the statistical distribution. Just will make some idea. If you know the range, we can talk about the class intervals. From the range value, from the range we can decide whether the class interval size of the class will be 4 or 5, like that we can make some decisions. That's it. Right? 1,000, even you can have the class interval in terms of thousands. If it is a population census, obviously it will be in the range of thousands or 10,000s or lakhs. Clear? Then, apart from that, the measurement of quartiles, not deviation, quartiles, deciles, percentiles, all are called as the univariate analysis, because with one variable you are doing all those things. How many of you know the importance of quartile deviation? Quartile deviation. You are studied in B.Ed, everybody should have taken a table, you have conducted the test for B.Ed people in the school, and you have taken all these things and you have written the test and measurement notebook and you have calculated the rank order correlation. Right? You did it or not in the B.Ed? That is must in the B.Ed course. Right? But how many of you know the importance of quartile deviation? As a research scholar, forgot about the B.Ed. As a research scholar, you have done all these basics for your coursework. Quartile deviation is said to be the probable error of the distribution. Quartile deviation is the probable error of the distribution. If the probable error is less than 10%, if the probable error is less than 10% of the whole distribution. For example, in the previous calculation, I have taken 10 numbers, 10 cases. Okay? So out of 10% is 1. If the quartile deviation value is less than 1, then we can assume homogeneity among the variance. Homogeneity among the variance, for which only we are calculating the quartile deviation. Then, quartile deviation is little bit tough value. The condition is very tough, 10%. 10%. So up to 10% only we are giving lenience. So we are going for the better value which has better accuracy. Better accuracy, that is the purpose of the standard deviation. That is the purpose of the standard deviation. Because in standard deviation, you will calculate the mean, from the mean how the people are deviated, how the values are deviated. How the values are deviated. So, when you are calculating the average, from the average how you are deviating, that will give the better measurement than the quartile deviation. Why? Somebody should have asked the question why, otherwise I have raised the question why. Nobody raised the question why, sir. So I have raised the question why. Why? We take the normal probability curve. We take the normal probability curve. To think of the quartile deviation, see, only few extreme values may be here. Similarly, few lesser extreme values may be here. All the other values may be dense to over here. Dense to over here. So, in the quartile deviation, there is a higher chance of error. Higher chance of error. Rather, if we calculate the mean for the whole value, from the mean, how each values are deviated, plus, minus. This will be the better error. This will be the better error. So, standard deviation is the better error. See, both are error only. Both are error. Which is the better error? See how we are selecting certain things in the life. It is recorded, so I cannot talk so many things. Okay? So we are looking for the better worst always. We are not looking for the best. We are not looking for the best. We are looking for the better worst. All are worst. Among the worst, we are looking for the better worst. Better worst. Likewise.
Students are very sharp.
Yeah. They are laughing.
What you mean to say?
Okay? So we are looking for the better worst.
Girls are sharper than boys.
I am not talking about the husband. I am not talking about the guides. Okay. So I answer both of your queries, boys and girls. Okay, I am not talking about your. I am not talking about your guides. I am not talking about your husbands. Okay. So in terms of better worse, yeah. I am not for politics also. So we are always looking for the better worse, not the best, not the best. So quartile deviation is the error. Standard deviation is the better error. Standard deviation is a better error. That too, since it is the better error, we have some lenience in the better error. If the standard deviation value is less than 15% of the distribution, these are all the thumb rule. 15 for quartile deviation it is 10%. But for the standard deviation, which is also indicated in terms of sigma, the standard deviation is indicated in terms of sigma. For the standard deviation, there is some little bit lenience, 15% of the error. Then we can assume the homogeneity among the variants. Homogeneity among the variants. These are all the basic concepts. Now come back to the parametric statistics. Parametric statistics. We can use the parametric statistics under two conditions. There are two major conditions for the parametric statistics. To use the parametric statistics. One is normality of the distribution. Normality of the distribution, which means if you take the sample measure, it should be normal, more or less normal. Otherwise, in statistics, I think most of the scholars they didn't do. I know very well. But K-test is there. K-test for normality. K-test for normality. First, we have to check the K value for normality, based on which only you should decide. You should decide whether you should go for parametric statistics or non-parametric statistics. Like hypothesis myopia, or people have the parametric myopia too. Parametric myopia too. All we want to use only the parametric statistics because we don't know how to interpret the non-parametric statistics. The simple reason is we don't know how to interpret the non-parametric statistics. Okay, not any secret behind that. We don't know because we don't read. We don't read. So all we want to use the parametric statistics. That is why we cook up some data and we used to say that our data is normal. That is absolutely wrong. See, in research there is ethics as well as the integrity. Integrity. See, in research you should ensure that you should not give any misleading information to the next generation researchers. You should not give any misleading information or false information to the next generation, because your research finding will be the review for the other people. Review of related research for the other people. Am I right? So you should not give the misleading information. There comes your integrity. There comes your integrity. Okay. So coming back, normality, K-test is used to help. K-test we are using it to establish the normality of the data. This is one side. But in general, how can we establish the normality? And homogeneity among the variants, K-test will not be helpful. It ensures only the normality of the variants. Homogeneity among the variants means more or less the selected sample have the similar characteristics. This packet. These packets have the similar characteristics. Only then I can generalize the finding of the sample to the whole population. Only then I can generalize the sample value to the whole population. So number one, if you calculate the measures of central tendency, if the curve is normal, your mean median mode should be more or less with the same value. That is the condition. Normality of distribution. I hope you know mean median mode, but without knowing why we are using it, we are calculating it. Am I correct? Or you know this purpose? How many of you know this purpose? No one knows. Pathetic. Right? So, if the mean median mode will be more or less equal, well, not exactly equal. more or less equal, 35.5, 35.6, 35.4. Like that, if you have the mean median mode, that indicates that you are fulfilling the first condition, normality of the distribution. You don't even go for the k-test. You don't even go for the k-test. Then second part, homogeneity among the variants. You must come for the measures of dispersion. Measures of dispersion. Check whether the quartile deviation value is less than 10%. If not, go for standard deviation. Whether the standard deviation of the measurement is less than 15%. Then, if it is less than 50%, you can assume the homogeneity among the variants. If only these two conditions are fulfilled, you should go for the use of parametric statistics. Parametric statistics. Then, the rank order correlation is the non-parametric statistic because it's in the ordinal scale. Because it is in the ordinal scale. Then product moment correlation coefficient, it is in the ratio scale, it is the parametric statistics. So the third condition is the data should be either in the interval or ratio scale. The data, the collected data should be either in the interval or ratio scale. Only then you should use the parametric statistics. Hope you got the idea when and where to use the parametric statistics. Then by means 2. By means 2. Otherwise you should go for non-parametric statistics. By means 2. Okay. Your t-test, the popular student distribution t-test, is the bivariate analysis. Carl Pearson product moment correlation, rank order correlation, all are coming under the bivariate analysis. All are coming under the bivariate analysis. Then z-test. Z-test. This is also comes under bivariate analysis. Right. Multivariate analysis. Please take simple regression. This is comes under the bivariate analysis. Influence of one variable over the other. One variable over the other. Regression comes under bivariate analysis if it is limited with the one independent and one dependent variable. All the other things, multiple correlation, canonical correlation, multiple regression, multiple correlation, multiple regression, multiple correlation, canonical correlation, multiple regression, path analysis, etc. comes under multivariate analysis. This is the basic classification about the statistical analysis. Basic classification about the statistical analysis. Shall we move further? Are you clear? Are you sleeping? Huh? Actually, in statistics we need certain stories. Okay. Actually, for your punctuality, I want to tell you a story. Because morning itself I have noticed how punctual you are. Okay. Then one Indian and one Japanese, they are the close friends. They worked in Dubai for about yes.
Multi is an example.
Multivariate. Canonical correlation. You are involving more than two variables. More than two variables. Okay. Morning I spoke about the multiple correlation, which is coming under the multivariate analysis. Path analysis, ANOVA, MANOVA, all are coming under. ANACOVA, not anaconda. ANACOVA, analysis of covariance. That analysis of covariance is nothing but the correlation. Morning itself I told R is nothing but covariation. R is nothing but covariation. See, we are assuming too much about the statistics without understanding the basics. If you know the basics, all the statistics are nothing. We have to understand the basics. Okay, so there was a friends, one is Japanese, another one is an Indian, and both were working in the Dubai. For more than 35 years they were friends. Suddenly they met with an accident, they have died. Both are died. They were taken before the Yamadharma, you know the Yamadharma, Chitragupta and accounting and all. Okay, they were brought before Yamadharma. Now, Yamadharma was asking what is the good things they have done and bad things they have done. Both of them are 420 fellows, they never done good things in their lives. Okay, they are 420s. So they never, 420 section, IPC. Cheating, blah, blah, blah. So both of them are 420s. So they never done good things in their life. They never done good things in their life. And what was, according to the judgment, Yamadharma has granted hell for the Japanese. Okay. Similarly to the Indian. Now Chitragupta was telling, Prabhu, both of them are close friends. Both of them are close friends. So if they offer for the Indian hell or Japanese hell, we can send them together because they were together for 35 years of cheating other people. So we can send them for the same hell. Jamadharma has agreed. Now, first they asked the Japanese whether you want to go to the Indian hell with this fellow. He said, no, I will go to only Japanese hell. I will go to only Japanese hell. Okay, so, okay, it was over. Now the Indian wala, right? He was asking whether you want to go to the Japanese hell or Indian hell. Whether you want to go to the Japanese hell or Indian hell. This fellow asked, what is the difference between Japanese hell and the Indian hell? Okay? And you know, Japanese people are the number one patriotists in the world. Probably you might be knowing about that. After the Second World War, Hiroshima and Nagasaki was spoiled with the atom bomb, little boy and little girl. Everybody thought that Japan will not come up even for the next 200 years. But within the short span of duration, within 30 years, Japan came number one in the world. They became the superpower and they became the permanent member in the UN. They became the permanent member in the UN. And now they are in the position to borrow loans for the big brother America. The USA, United States of America. So that is how they are the patriots. Indian wala he asked for what is the difference between, because we are the people who know so many things. And he asked, what is the difference between Indian hell and Japanese hell? Then Chitragupta said, in Japanese hell you will be boiled in the hot oil at 10 o'clock once, and in the Indian hell you will be boiled for 5 times a day. 5 times a day. Then for your surprise, this fellow said that I will go to the Indian hell. I will go to the Indian hell. Now the Japanese, he cannot control his emotion and he hugged this fellow and he started weeping like anything. I thought the Japanese are number one in the patriotism, but you have beaten that. You know that you have been boiled in the oil for 5 times, but still you are going to the Indian hell. This fellow said, hey, don't make noise and keep quiet. This fellow was astonished. Why? Why? In the murmuring voice he was asking. This fellow said, you people are idiots. On the name of punctuality, you will be boiled in the oil exactly at 10 o'clock. But we are not like that. We are not like that. First in the morning, we will see the good time, bad time, Ragagala, Yamaganda, this, that and all. Then we will discuss about in which direction we have to keep the stove. Whether it is in the north or east or south or west, we have Vastu. We have to see the Vastu. Then we will have a big discussion that whom to be called to cut the oil and open the oil. Okay, we have the big problem. Then whom to be boiled in the oil. Whom to be boiled in the oil, and we will have the fight and we will be throwing all those things and we never be boiled in the oil. We never be boiled in the oil. See, even in the hell our punctuality is like that. Okay, Indian punctuality means 20 minutes late. Think of your tea time and how you are coming. I am not pointing at you people. Just instantly I want to say this story. So Indian punctuality. Indian punctuality. I am not pointing at you people in the morning and afternoon. How did you come? Okay, that is not my intention. Okay, if you correlate it, that's your problem. Okay, coming back to the point. So remember again, we have 3 statistical analysis. We have the 3 major dimensions: univariate, bivariate, and multivariate. And in univariate, we have measures of standard tendency, measures of dispersion or deviation, etc., etc. Decile, quartile, Einstein, everything. Then bivariate analysis, we have 2 variables. So t-test, t-test, correlation, z-test, and simple regression. Then canonical, more than 2 means it talks about multivariate. So canonical correlation, multiple regression, ANOVA, ANACOVA, etc., etc. It comes under path analysis. Everything is coming under the multivariate analysis. Then even within these analysis, we have both parametric and non-parametric test. Correlation, product moment is the parametric correlation. Rank order is the non-parametric correlation. Because in rank order, we are using the ordinal scale. In product moment, we are using the ratio scale. So there are 3 important conditions to use the parametric or non-parametric statistics, or to use the parametric statistics. First condition, normality of distribution. Normality of distribution can be checked with the k value or if the mean median mode, the measures of central tendency is more or less equal, we assume the normality of the distribution. Then second condition, homogeneity among the variance. Homogeneity among the variance. Quartile deviation is the probable error of the distribution. If the quartile deviation value is less than 10% of the overall distribution, for example, if there are 100 measurement, out of 100, if the quartile deviation is less than 10, we assume the homogeneity among the variance. We have little bit lenience with the standard error. Standard error is the error, the squared error from the mean value. That is the formula. As per the formula, this is the squared distance from the mean value where we measure the error. So it has little bit lenience, like if the standard deviation is less than 15%, we can assume the homogeneity among the variance, among the variables. Then the third condition is, if the data is in the nominal or ordinal scale, you should go for non-parametric. If the data is interval and ratio scale, we can go for parametric. That's it. Is it very difficult to understand? I have summarized everything. Right. Coming back. So what is correlation and causation? Almost I am taking the whole research methodology instead of the topic. Correlation and causation. Actually, morning itself I told you, there is a relationship and there is the influence of one people over the other. There is a relationship as well as influence of one over the other. Clear? So, correlation is not causation. Causation is nothing but finding out the cause and effect relationship between the variables. Causation is nothing but finding out the cause and effect relationship between the variables. But sometimes the cause and effect relationship, if two variables are correlated, it could be for any one of the following reasons. Number one, third party influence. Normally we are not measuring the third party influence in the correlation. That is why we are not using the correlation directly for any prediction. Either we are converting the t-value or we are just saying that there is a relationship. There exists a relationship. Number two, mutual dependence, cause and effect. It may be due to cause and effect, but we are not directly measuring it. If you want to, instead of you want to make some predictions, you have to square the R value from where you can predict the cause and effect. Morning we have done it. R square the R value. Number three, pure chance. Pure chance. Even by our birth is by pure chance, am I right? Am I right? Because we have never planned and I will born only with this father. Otherwise, you would have planned with the Ambani family. Why we are planning with these parents? See, for the July wedding, how many things they are making from the month of March onwards. Am I right? You would have planned in the Ambani family, Ambani or Adani family.
No, Adani is gone.
Huh? Yes?
No, Adani is gone.
Adani is where?
Not where. He's getting down in the.
But still you cannot imagine his property value. The next. Yeah, morning itself we have discussed about the three types of correlation. Next. Yeah, wait. Little bit upper. No sir, next. No, based on the number of the previous line. Yeah, based on the ratio of variation between the variables, correlation can be classified as linear correlation and non-linear. Morning we have seen.
Yes.
Okay, I have given all the notes there. Next. Based on the number of variables involved, correlation can be classified as simple correlation or partial correlation. Next. Multiple correlation. I didn't use the word partial correlation, but partial correlation is also possible. Okay, weak correlation. Partial correlation is nothing but weak correlation. The next, no. Degree of correlation. We have either perfect correlation, in which we have the positive, negative, or zero correlation. Already we have seen all these things. Next. See the table. Come on, down. Yeah, this is important. See the perfect correlation, if it is positive, +1, if it is negative, -1. Then very high degree correlation. The plus 0.9 is said to be very high correlation. Fairly high degree of correlation, normally between 0.75 to 0.9 for either side. The negative side also -0.75 to -0.9. Then moderate degree between 0.25 to 0.75. Remember, it is like your quartile between the first quartile and the third quartile. It's not exactly the same, first quartile and third quartile, more or less similar. More or less similar. Then zero or no correlation, low correlation, low degree of correlation between, that is called as partial correlation, between 0 to 0.25. Then no correlation, zero correlation or no correlation, 0. Okay, which is the correlation portion is over. But I want to introduce two more correlation if you wish. I am not going to calculate anything, don't afraid of that. There are certain correlation coefficients, we have other correlation. One is biserial correlation. The other correlation is called as biserial. You want biserial or point biserial? Other next one is point biserial. But you know what is biserial? Okay, I am happy that you heard of. Okay, biserial correlation. When we use the biserial correlation, for example, we have the scores of the subject, scores of the people. Okay, we know that maximum score is 100. Maximum score is 100. Then we have the maximum score 100. For each people we have the different scores, like 85. But for the 100 score, we don't know how many questions are there. One mark questions are there in some examination, 2 mark question, 5 mark question, 8 mark question, 7 mark question, 10 mark question. We have various set of questions. Right. Here we have the next continuum, next dichotomous as the mark is the continuous variable. Total mark is the continuous variable. And how many right, how many wrong? How many right, how many wrong? So numerical value we are having. For example, there are 30 questions. 17 questions the answers are right, and 13 questions the answers are wrong. Answers are wrong. You may raise the next question. So why we break our head for all these things? Nowadays in all the competitive examinations we have the negative marking. So we will calculate how many wrongs, and for each right answer, for example, if you take the NEET examination, for each right answer they will give the score 4 and -1 for each wrong answer. You will be totally getting confused. Now we want to get the correlation, so we have the biserial correlation. One continuous variable and one dichotomous, di means two, dichotomous variable, ty, dichotomous variable means one continuous and one dichotomous variable means we can go for, dichotomous variable is also number, continuous variable. Dichotomous variable is also continuous variable. And another situation, we have one continuous variable and the another dichotomous variable is like yes or no. Yes, no, true, false. True, false. So, what? Yes? Dichotomous means two. We have two options. Yes, no is the two option. This is not with the single variable. We have two options. With a single variable, we have right or wrong. But right, we are counting the number we are writing. Wrong, we are counting the number we are writing. But here the situation is, for yes you can assign 1, for no you can assign 0. For yes you can assign 1, for no you can assign 0. If this is the situation, we could go for point biserial correlation. If this is the situation, we should go for point biserial correlation. Then, with the same yes-no type here, yes-no type is there, and we have the gender also, male, female. So both the variables are dichotomous variable. Both the variables are dichotomous variable. Then we will go for tetrachoric correlation. Tetrachoric. Tetrachoric correlation. Tetrachoric correlation. And you will come across the word phi coefficient. PHI, phi coefficient. Okay? There are similarity between tetrachoric correlation and the phi coefficient. The basic difference is, in the tetrachoric correlation, we are calculating only with the dichotomous variable and we can calculate the differences. But in the phi coefficient, we will work it with the continuous variables in the dichotomy. That is why phi coefficient is the accurate measure than the dichotomous. So biserial, point biserial correlation is useful in establishing the reliability of some of the tests. There are two kinds of tests. One is the speed test and the other one is the power test. speed test and the power test. Most of your entrance exam are the achievement test of the speed test. But some of the power tests are there. Power tests are there. For example, when you go for police selection or military selection, they will check your power. They will check your arm dexterity, finger dexterity, tweezer dexterity, how we are handling the tweezers. So those are all called as the power test. Those are all called as power test. In these power tests, we cannot get the direct numbers, continuous numbers. So we use the point biserial correlation to establish the reliability of the power test. I am not going above your biserial, point biserial, tetragonic and pi coefficient. Okay, so these are all the extra material, extra correlation. Apart from, everybody knows about the Spearman rank order and Karl Pearson product moment. But these are all some other correlation coefficient. These are all the information I am providing just because if you want to go for the UGC NET examination. In NET examination, these kind of clarification, these kind of discrimination only they will raise. It's very difficult to decide. That's why many of the people are failing in the NET examination. Right? If you are thorough with the methodology and statistics, your 90% marks will be scored for in the NET examination. Your subject is just 10 to 15% only, in my opinion. Because if you are strong with the statistics, you will be strong with the basic reasoning. Right? Aptitude and all, being the M.Ed and above level, you know what is logically expected in the question. So you can reason out. You can reason out. So clearing the NET examination is nothing. But the only thing you are thorough with the stat and the methodology portion. Stat and methodology portion. But in my opinion, better go for the NET exam. Though you are the PhD scholar here, go for the NET exam. If you get the fellowship value will be 35,000. You will not get that much scholarship in your university. For 5 years, you will get 35,000 per month. It's like the salary in many of the colleges. Okay, so go for the UGC JRF. That's my humble suggestion for all the research scholars. One should not do the PhD without fellowship. Okay? After 22 years or 23 years, we should not be the burden for the family. We should feel ashamed of it. So we should clear the NET examination. Coming back. So with this correlation part is over. So next slide you can project. The previous one you have shown for population and one tail and two tail. The name was given as within the same folder. One tail and two tail, Professor S. Kajraval they put. No, new folder 2. New folder 2. No, new folder 1 then. Go back, new folder 1. No? Come out. Previously you have projected. My name is not there. Yeah. Last but one. Last but one. Type 1 and type 2 errors. Yeah. Open it. First slide is empty. Go to the second slide. Yeah. Go for the projection. Presentation. PPT presentation. Shift F5 or Control F5. Yeah. Statistical inference. So already I spoke about it. So population, collection of subjects or objects of interest, not necessarily people, even about the categories. Then sample subset of the population used to make inference about the characteristics of the population. Already I have explained. With the figure I have explained. Then population parameter, numerical characteristics of a population, a fixed and usually unknown quantity. That is why, assuming the normal distribution, we are generalizing the sample mean as the population mean. Data, values measured or recorded on the sample. Okay, mean is the data, median is the data, etc. Statistic and data. Then data, actually we use this word again as a colloquial word. Datum is the right word. Okay, and you people are writing datas. It's not for a joke. Many people are writing like that only, datas. Data itself is singular. There are certain words in English we can use it for singular as well as for plural. So data is such a kind of word. But statistically speaking, datum is the right terminology. Datum, D-A-T-U-M. Datum is the right terminology. Then sample statistic, numerical characteristics of sample such as mean, proportional variance, etc. I already told about it. Next. So statistical inferences, this is what I have explained. This is what I have explained. From the population, we are making the inferences about so from the sample, we are making the inferences about the whole population. Okay? Where we use the word hypothesis and hypothesis testing. Where we use the terminology hypothesis and hypothesis testing. Are you clear with this? And next. Yeah. The process of drawing inference about a population on the basis of information contained in a sample taken from the population is called as statistical inference. We are using two methods. One is estimation of parameter and testing the hypothesis. Testing the hypothesis. Next. Okay. The most important thing is type 1 and type 2 error. Type 1 and type 2 error. Normally we will get the chance of accepting or rejecting the null hypothesis wrongly. Accepting or rejecting the null hypothesis. So it was shown in the figure. Conclusion from the statistical analysis, it is like the 2 by 2 matrix. One side we have null hypothesis true, null hypothesis is not false or not true. Then other side we have either we have to accept the null hypothesis, we have to reject the null hypothesis. Look at here, null hypothesis is true. What is null hypothesis? Null hypothesis states that there is no difference between the two groups or two variables. There is no difference between two groups or two variables, whatsoever it may be. Now, that is the null hypothesis. So null hypothesis is correct. There is no difference between you and me. There is no difference between you and me, and you are accepting the null hypothesis. You are accepting the null hypothesis. Is it a right decision or wrong decision? Don't see there. Apply your logic so that you will not forget. Apply your logic. See, there is no difference between you and me. This is null hypothesis also. You are accepting the null hypothesis. Is it the right decision or wrong decision?
Wrong decision.
Right decision. There is no difference between you and me. There is no difference between you and me. So you are accepting the null hypothesis. This is the null hypothesis also. We are not differing. There is no significant difference between you and me. This is the null hypothesis. So you are accepting the null hypothesis. It is the right decision. Similarly, actually null hypothesis is false. Okay? Null hypothesis false means the hypothesis is nothing but alternate hypothesis we want. HA, H0, null hypothesis is indicated as H0. Again, as usual, I will be confusing you as per the statistics. The first condition, we are going for the null hypothesis. Null hypothesis is indicated as H0. So if H0 is rejected, we need alternate hypothesis, that is called as HA. Right. This is one situation. I am using the hypothesis. That is directional hypothesis. Okay? You and me differ significantly in many qualities. Like my height, weight. You cannot compromise with me. Okay? You cannot compare me also, height and weight. So definitely we differ. So there is a significant difference between you and me. This is the hypothesis. Then we need alternate hypothesis. What will be the alternate hypothesis? See, forget this. Null hypothesis, we don't differ. This is null hypothesis. Don't is the null hypothesis. Then do is the we do differ. This is the alternate hypothesis. Are you clear? Okay. Forget this. Now I am framing the hypothesis. That is the direction hypothesis. Do is the hypothesis. Then what is alternative hypothesis? Don't. Common sense. Don't. So in this case, your alternative hypothesis is nothing but your null hypothesis. Are you clear? That's what I want to say. It's very simple. When we have the directional or non-directional hypothesis, the alternative will be null hypothesis. If you have the hypothesis, at least from here you can don't do. Then do means then alternative will be no. Are you clear with this? And come back here. So actually we don't and we accept the null hypothesis. the two, we accept the alternative hypothesis or hypothesis. Actually, here H is nothing but HA here. H is nothing but HA. Simple. Yes or no? No or yes? Avla. Clear? So this is how in the book they will confuse you, but I am using the terminology don't do, and I will give you a simple example. Many people will be confused with these terminologies. If there is the hypothesis, then the alternative hypothesis will be null hypothesis. You will be confused totally. So this is a simple example. Simple example. Right. We need some alternative. Okay? Don't check for alternative everywhere. You will be into a problem. Okay? We need some alternative for hypothesis testing. We need some alternatives for hypothesis testing. So we are forming it. Come here now. So there is no difference. We don't. We accept the null hypothesis, which is the right decision. Actually, we differ. We differ. We don't, but we reject the null hypothesis. Sorry. First, let me complete the typo error. We don't differ. We accept the null hypothesis. This is the right decision. But we don't, but we reject the null hypothesis. We don't differ means we reject the null. We have to reject the null hypothesis if we do not differ. But we have the difference and we reject the null hypothesis. This is called as typo error or alpha error. Typo error or alpha error. Second situation, null hypothesis is false. Null hypothesis is false means we differ. Null hypothesis is false means we differ, but we accept the null hypothesis. We differ, but we are stating that there is no difference. We differ, but by accepting the null hypothesis, we are going to state that there is no difference. That is the wrong decision. That is the wrong decision. That is causing the beta error or type 2 error. Type 2 error. Normally, type 2 error, alpha plus beta is equals to always 1. Alpha plus beta is always equals to 1. If you have more type 1 error, then lesser type 2 error. Then, if you have more type 2 error, there will be lesser type 1 error. Okay, what is type 1 error? What is type 2 error? Next slide. What is type 1 error and what is type 2 error? Okay, next slide. This I have explained. Next slide. Yeah, type 1 error. Type 1 error and type 2 error are said to be the chance error. Type 1 and type 2 are said to be the chance error. Type 1 error, the chance or probability that you will reject a null hypothesis that should not be rejected. Just now I told. Then this will result in you deciding two groups are different or two variables are related when they are really not. They are really not. Then the probability of a type 1 error is called as alpha error. I have explained all these things. Similarly, the type 2, the chance or probability that you will not reject null hypothesis when it should be rejected. False. Okay, with sentence you are getting confusion, but I chose a simple example. Okay, do, don't. Then this will result in you deciding two groups are not different or two variables are not related when they are really. So we actually really differ, but we are taking the null hypothesis. That's the meaning of it. Then the probability of a type 2 error is called beta. Next. Then with the example we can understand what will be the consequences of the type 1 and type 2 error. See, let me talk about the safety alarm. Everywhere nowadays we have the safety alarm. Okay? See, without any threat we are ringing the safety alarm. With real threat we forget to ring the safety alarm. With real threat we forget to ring the safety alarm. Both have its own consequences. Look at here. One minus error is called as the type 1 error is related with the confidence level. Type 1 error is related with your confidence level. So I forget to ring the bell, so you lose confidence on me. I forget to ring the bell, you lose confidence on me. Or unwantedly I rang the bell, you lose confidence on me. You lose confidence on me. So this is with regard to alpha error. But beta error, this is the power. If there is the real threat, you forget to ring the bell, there will be the huge fire accident. Life of many people will be gone. So this is with the power of the test. Power of the test. So if alpha error occurs, we can neglect it. Neglect it. But if there is a beta error, that is related with the power of the test. That is related with the power of the, hope you get the difference. Why beta error is so serious? Why beta error is so serious? See, even if there is, if the null hypothesis is there, we have accepted it. So alpha error is not much serious error. It's not a much serious error. But if there is huge difference, we reject it. That will have the serious consequences. That is why beta error is viewed as the serious error. Are you getting me or not? See, actually there is no threat. There is no threat even for the even for just cautioning you. I not rang the bell. It is not the danger. It's not a big danger. If there is a huge threat, I forget to ring the bell, which will cost the life of people. Which will cost the life of people. That is why beta error is the serious error. Type 2 error is the serious error. Then example of fire alarm. False fire alarm leading to inconvenience. Okay. We will be disturbed for 10 minutes and we will be assembled back. Like a tea break. Then missed fire leading to disaster. Missed fire alarm leading to disaster. Then effects on process. Unnecessary cost increase due to frequent changes. Okay, 10 minutes, 10 minutes, you are seeing it at 10 minutes, but 60 into 10 minutes, 600 human minutes are wasted. So unnecessary cost. Unnecessary cost. Then defects may be produced. We lost the human life. We lost the human life. About 10 people are died in the fire accident. Okay, we lost the human life. So defects may be produced. This is unwanted thing. Unwanted thing. 600 human minutes and 6 people life is more or less equal? No. We are habituated in wasting most of the time. That is not a big problem for us. That's not a big problem for us. But losing the life of 6 people. So defects may be produced. The control method usually fixed at a predetermined level, 1%, 5% or 10% confidence. Okay, thereby easily we can reduce the alpha error. So the level of confidence or level of significance is associated with your alpha error. Okay. So not even we are fixing the 10% level of confidence, we fix 5% or 1%. With a human variable it is very difficult to fix the 1%, so we prefer the 5%. Then usually controlled to less than 10% by appropriate sample size. The beta error can be reduced by increasing the sample size. The beta error can be reduced by increasing the sample size. Generally for survey research, we used to say that 10% of the population should be selected as the sample. That's what the fixation. Approximately less than 10%. Approximately, sorry, greater than 10%. 10% and above is said to be the greater sample or effective sample, effect sample size. But for the experimental intervention, even n is equals to 30 is the adequate sample, statistically adequate sample. Statistically adequate sample because your t distribution is based on n is equals to 30. The student's t distribution by William Gossett is based on n is equals to 30. Even if it is n is equals to 30, we can go for parametric statistics, the t-test. The t-test. Then simple definition, innocent declared as guilty. Then guilty declared as innocent. If you declare the innocent as guilty, okay, sometimes he will feel, but he will become normal. If you declare the guilty as innocent, he will be the disaster for the entire family, entire university or entire office or the entire country. Entire country. Hope you got some idea about these things. Simple thumb rule. Alpha error we can ignore to some extent. Beta error, it's a serious error. So how to reduce beta error? Increase the sample size. That's it. You got the idea about alpha and beta? So already you would have told this. But statistically you should know all these things. That is my point. That is why I have been invited from all the way from Salem to Tirupati. Next slide. So, previous slide. Previous slide. This is the best example, you will not forget. See, type 1 error, you are pregnant. You are informing a male member as pregnant. Okay? Nothing wrong. He will be checking his stomach and he will forget that. He will forget that. But type 2 error, false negative. You are informing the pregnant lady as you are not pregnant. Not pregnant. If it is so, she will have the fear that whether she will have the cancer inside the stomach, And you know how our doctors are functioning, how our hospitals are functioning, how much machine and cost involved on that process. I don't want to tell explicitly. So that is a disaster. That is a disaster. Okay, now you will not forget it. Next slide. So true positive, you are pregnant. False positive, type 1 error, you are pregnant. You are informing the male member. Type 2 error. True negative, you are not pregnant, but false negative, you are pregnant. Type 2 error. So type 2 error is the serious error. Type 2 error is with this picture you can understand everything. Which is serious? Which is more dangerous? Right. The next. The T distribution. Everywhere we are popularly using the T distribution. T distribution. Before which you should know one thing about the one-tailed test and two-tailed test. One-tailed and two-tailed test. Normally, if you take the normal probability curve, I think I'm overloading the information, I hope so. There are too much of information, correct?
Yes.
Yeah, that's the problem with the statistics. But I have to cover whatever the topic assigned to me. Complete it. Finish. Within 10 minutes I will finish it, don't worry. It's not going inside. Sir, shall we stop? Tomorrow morning again I will break their head with these statistics. They want to stop. Okay, you can ask some of see.
If you have any doubt,
You can raise your queries.
alpha error, beta error.
Alpha error, beta error, measures of central tendency, measures of dispersion or deviation. Anything you can ask, correlation or any other statistics.
Most of the cover this area. Next.
See, every year we have 30 students in psychology. Every year minimum 4 to 6 students are clearing UGC net exam from our
I
department.
have a question
Yes, please, madam.
from morning session.
Yes.
So whatever you told.
Because you are not in the afternoon session. Yeah.
Yes.
Vaishnavi.
Very true. I tried to come, but there was a meeting. and so-
Okay, no issues.
You mentioned the word called psychology thesis. What did you mean by that in the morning?
Psychology.
Are there theses which is specially for psychology, or the title was based on psychological?
Psychological topic I said, not
So
psychology.
is there any format for that?
Yeah, APA format is there.
Okay.
In education, you may not use the APA, American Psychology Association format. But we have to adopt the APA format. In the APA format, we will not mention the tables everywhere. Okay? We'll mention the mean value, which is the probability value is slash to a p less than 0.05, p greater than 0. Likewise, we will mention. We will not mention the table at all.
And if my understanding is correct, you have also mentioned that less of statistical analysis happens
Yeah.
in that thesis.
Yeah.
Which means
Because not less of statistics. See, only in psychology we use all kind of statistics. You could see the psychologists are the good statisticians. Most of the psychologists are good statisticians because they are concerned with the tool construction, test construction and all the other things. Right? For your information, whenever my PhD scholars are doing the thesis, I used to emphasize them either to develop and standardize a scale or develop the training module and standardize the same. Because that's our real contribution for the PhD. Yeah. Okay. So that's not like that. You misunderstood that. See, we will not give the statistical interpretation much. Many people are writing the mean value is 21.86, which indicates that this group is having the higher value. This kind of interpretation will not be there.
Where in psychology or in education?
In psychology, we don't use. Okay, straight away will say they differ. This group has the higher value, statistically significantly higher value, and characteristics interpretation. That's how it should be written. See, in many of the, not only for psychology, in many of the foreign universities, psychology and education are under the same umbrella. They are called a School of Psychology and Education or Education and Psychology. For your information, many of the psychology departments are under education departments. Many of the psychology departments are under the education department, either under the philosophy or education departments. Nowadays, mostly under the education department. School of Education and Psychology, not psychology and education, many of the foreign universities. Education and psychology, they work together. Both of them are concentrating on the tool constructions, the training module construction and all. Right. So coming back. So most of the journals, the quality journals, okay, I don't know whether in your university you have the compulsion of submitting the paper for Scopus Index journal. Yes sir? Yes? No? You have the care listed journal, am I right? Care listed journal. But in our university, it's the Scopus journal. Science people, they should publish minimum one paper in the SCE journal, and social science, humanities and arts, we have to publish at least one paper in the Scopus index journal. Otherwise, our students cannot submit the synopsis. One Scopus, one care list. One Scopus, one care list. You know the result? We got NAC A++, 3.63 in the second cycle, the third cycle we got. Previously we are with 3.12 or something, NAC A in 2015. Now we got 3.63 because of this one area. This one area brought the value like anything. Right. That too under the different category score, NAC score. Our research score is greater than Indian Institute of Science score. Indian Institute of Science, they had 3.56 in the research domain, but we got 3.76 in the research domain. Just because of this paper compulsion. Just because, so one of the work motivation theory says that people work only because of compulsion. Okay? When I was guiding the scholars in the initial stage, I used to compel them to go for the international journals, but they won't do it. Sir, why you are insisting that? Now, I am not insisting unless you are completing one paper in that journal, you cannot submit your thesis. You cannot submit your synopsis. You cannot submit your synopsis, but it brought the university to the different level. It brought the university to the different level. So even my request for the Sanskrit University or the Central University, you can change the norms. Minimum one Scopus paper they should publish. Okay, so that the university face value will be increased like anything. Right? Already you have the Central University, you have fair chances of getting the funds. If you have the NAC A++. The advantage with the Central University plus NAC A++ is you can run any course according to your convenience if you have NAC A++ and a Central University. At least we have to get the permission from the UGC, being a state university. Being a Central University, you don't bother about anything if you have NAC A++. These are all some of the advantages. And for you people, right, my scholars, no one is unemployed, number one. Number two, most of the scholars, they are placed with 1 lakh and above salary. Not even the UGC scale is not even 1 lakh in the initial stage. Most of my scholars are placed with 1 lakh plus. 1 lakh plus. Because of the 4 papers, 3 papers they have. See, nowadays private universities are coming up equally with the government universities. That do you know about the NEP? Out of the NEP, most of the government universities will be like the private universities. But private universities, they spend a lot of amount for the staff salary just to promote the research. Just to promote the research. So, my humble request is after PhD, don't think about only Sanskrit University, Sanskrit College. You have to come out. You have to come out, which is possible only when you have the quality publication. Quality publication. It's very simple to publish. For example, if you want to publish an article in a particular journal, download minimum 10 to 15 articles from the same journal. Read, reread and recite. Then jot down the points, in what angle they have done the article. If it is a review article, okay, site space, using the site space analysis, we can do the meta-analysis and we can write the article. So, you just go through how they have done it. How they have done it. Then, using the same thumb rule, you can write your article. There are many software with the minimal cost they are doing the language editing. Language editing. Before sending the article to any journal, any quality journal, do the language editing. Do the language editing. Then send the article. Okay? It will take, normally initial stage you will be upset because immediately within 4 days it will come for the first rejection. Not revision, first rejection. Okay? Don't lose the tempo. Revise it and send it back. Revise it and send it back. Within few months you will be getting the revisions. From the revision you can learn a lot. You can learn a lot. Okay? See, why I am talking about all the areas of research methodology? Because of the revisions. Because of the revisions of the papers. I am also a reviewer in many of the international journals. So because of the revisions of the papers. So do it and you can publish a quality article. Right. Number is least bothered. Number is least bothered. From 95 I am publishing articles. Till today I have published only 93 articles in my life.
So what are the standard format?
You should go to the same journal. There is no standard format for a single journal, for all the journals. That's what I said. If you decide the topic, decide the journal, read the articles from the journal. Then you work upon it. Okay? I insist the publication with the scholars because that will be your face value tomorrow. Not your PhD thesis. Even if it is like the pillow, big pillow, nobody will read it. Nobody will read it. Well, with the review of related literature and introduction chapter, we can fill up even 300 pages. Who will read it? Right? But it's, all my theses are with 100 to 125 pages only. That's it. My thesis will be like the small thesis only. All my PhD thesis. Right? So quality matters, not quantity. Okay? So focus on publication because I heard that most of your research scholars told by Professor Chandrasekhar sir. That's why I'm insisting upon it. Right? Thank you.
गुरुभ्यो नमः। अद्य समयोजितायाः कार्यशालायाः सप्तमदिवसस्य चतुर्थसत्रार्धः भवति। अस्मिन् सत्रार्धे पेरिया विश्वविद्यालयः समागताः कादिरावन् महाभागाः महोदयाः statistical inference, correlation, statistical analysis and level of significance, one-tail error, two-tail error test इत्यादि विषयान् अधिकृत्य सम्यक्तया बोधितवन्तः। अतः इमान् महोदयान् विश्वविद्यालय पक्षतः कार्यशालाया पक्षतः शोध छात्र पक्षतः अपि तु मत् पक्षतः अपि हार्द्यं धन्यवादान् विनोमि। एवं च अस्य कार्यक्रमस्य निर्देशकवर्याः माननीय प्रोफेसर वेंकटराव महाभागाः एवं समन्वयकः प्रोफेसर आर चंद्रशेखर महाभागाः उपस्थिताः संयोजकः महोदयाः विविध प्रान्तेभ्यः आगताः आचार्याः उपस्थिताः शोध छात्राः सर्वान् हार्द्यं धन्यवादाः व्यहरामि।
पक्षतः इति उक्तवती खलु मम पतिदेव पक्षतः
विविध प्रान्तेभ्यः
मम गैड् पक्षतः इति वदतु।